This is number 28 from the 1994 state math counts competition. And when doing this problem, there are two very separate ways to do it. One way is to do it by thinking through the possible values for x and then figuring out what the answer is going to be. And another way to do it is to do it purely algebraically. If you're going to think through it, what you might do is just start trying some numbers. Like, for instance, if you try 0, it's very easy. Well, it says positive integers, so if you try 1, it's very easy to see that 3 minus 7 gives you negative 4, and the absolute value of negative 4 is 4, which is certainly less than 14. So 1 works. And so now we know that we don't have to try anything less than 1 because it says positive integers. And so then we can just start looking at some numbers. Well, as you start plugging numbers in, you realize that this just gradually starts getting bigger and bigger and bigger. And so every x is going to work until that gets too big. So let's just go ahead and make the assumption that some of these work until, let's say, we get to 6. If we try 6, you get 3 times 6 is 18 minus 7. Well, that's still less than or equal to 14 because 3 times 6 is 18. 18 minus 11 is 7 is 11. 11 is certainly less than 14. So 6 works. So then we could try 7. We get 21 minus 7. Take the absolute value. Is that less than or equal to 14? Yeah, so 7 works. But then when you try 8, you finally get to one that doesn't work because 24 minus 7 is 17. And 17 is not less than 14. So the correct answer is 7. The digits 1 through 7 all make this true. If you want to do this algebraically, you set up what's called a conjunction, which is two inequalities that are connected by an and. And the first thing you do is remove the parentheses, the absolute value signs like I did. And then the second thing you do is you remove them again, but this time you change the direction of the sign and change the sign of the number. That's our key fact with dealing with the absolute value. So it's going to be, when is 3x minus 7 greater than a negative 14? Change the direction of the sign, change the sign of the number. We solve these two equations. We get 3x is less than or equal to 21. X is less than or equal to 7, which we figured out here. So x has to be less than or equal to 0, because 7, because this is and. You look at this one, if you add 7 on both sides, you get 3x is greater than or equal to negative 7. So divide through by 3, and you get x is greater than or equal to negative 7/3. So that means we're looking for all of the x values that are between or greater than negative 7/3 and between or less than 7, or less than or equal to 7, which turn out to be 1, 2, 3, 4, 5, 6, 7. So once you find these two equations, then it's very easy on a number line to see what the correct answer is going to be.